All right, welcome to Notes 10.7. So today we are going to talk about equations of circles. And the definition of circle is the set of all points equidistant from a point. And when you combine that definition with a coordinate plane, what you get is an equation. So we are going to first consider the equation x squared plus y squared equals 25. And we are going to plot this on the coordinate plane. Now, the way you can plot any equation on a coordinate plane is just to pick values of x, plug them into the equation, and solve for values of y, and that gives you an ordered pair. So let's do that. We're going to start with my favorite value, which is 0. And so I'm going to substitute that in, and I get 0 squared plus y squared equals 25, which means that I have y squared equals 25, so y equals 5. But it also equals negative 5, because when I take the square root of something, it has both a positive and a negative root. So I have two pairs from that. I have 0, 5, and I have 0, negative 5. Let's pick another value. Let's pick 5. So now I have 5 squared plus y squared equals 25, which means that y has to equal 0. So I think you're getting the point. So I'm going to give you some more things to plug in, and you tell me what you get out. We're going to do negative 5. We're going to do 3. We're going to do 4. And then I want you to also consider negative 3 and negative 4. So go ahead and plug all those in and write me some ordered pairs over here on the side. Hit pause now, come back when you're done. Okay, so if you plugged everything in correctly, you should have gotten all the points that I have over here on the right now. So let's go ahead and let's plot them on our graph. So let's see, we've got 0, 5, 5, 0, 0, negative 5, negative 5, 0, and then we have all these other points. So let me see, negative 3, 4, negative 3, negative 4, 3, 4, 3, negative 4, negative 4, 3, negative 4, negative 3, 4, 3, and 4, negative 3. So you can see the circle starting to form, and I am absolutely terrible at drawing these, especially on this, but we will give it a shot. And so we connect all our pretty dots, and we form a quasi-circle. And that's actually not that bad for me, so yay me. Now when you think about that circle we just drew, or any circle on a coordinate plane, then you realize the radius of that circle has a length, and you can find that length with the distance formula. And so if you look over here at the circle on the right, we're going to call the point that is the center of the circle h comma k, and we're going to call the point that is on the circle x comma y, and then we've got radius r. And if I do the distance formula with that, I find out that my radius is equal to the difference of the x's squared, so x minus h squared, plus the difference of the y squared, so y minus k squared, and we square root that, and that's my distance formula. Well, if I square both sides, then what I actually have is the equation for a circle, and we call it the standard equation for a circle. And my center is always represented by h and k, and my radius is r, and then x and y stay x and y. So if I want to write the standard equation of a circle with a center at 0, negative 5, and a radius of 3.7, this is my h, this is my k, this is my r, and I plug all of those in. So it's going to be x minus 0 squared plus y minus a minus 5 squared equals 3.7 squared. And then we're going to clean it up a little bit. So we get x squared plus y plus 5 squared equals 13.69. And that is my equation for a circle with this center and this radius. So I would like you guys to write the standard equation of a circle. So just to remind you, x minus h squared plus y minus k squared equals r squared, with this circle right here, where the negative 1, 2 is the h comma k, and then we're given an additional point, negative 3, 4, in order to find the radius. So you're going to need to use the distance formula to find the radius, and then you can plug it all into your equation. So go ahead and do that and come back when you have your answer. Hit pause now. And you should have gotten x plus 1 squared plus y minus 2 squared equals 8. All right, moving on. Now we have an equation and we have to graph it. So our center, our HK, is going to be at 2, -3. And our radius is going to be 4. So we come out here to 2, -3, and they've told us that we are counting by 2s. So let me blow this up a second. So 2, -3 is 2, and then this would be -3 down here, and we're supposed to go 4 in every direction. So 4 up, 4 right, 4 down, and 4 left, and then again, I am not good at this, so I will be nice and lenient with you guys, but you just want to draw a pretty circle that goes through all of those points. That was actually a pretty good circle. Again, I'm feeling pretty good about myself. So for this next equation, it wants you to write the standard equation for a circle with the diameter, try that again, endpoints at -1, -1, and 5, 7, and I am going to ask you this question in the notes check. I'm going to ask you what H is, what K is, and what R is. Okay, finally we have this problem about a time capsule, and I've always felt like this is a stupid problem because you're smart enough to bury a time capsule, but you're not smart enough to write down exactly where you buried it, but whatever, let's suspend disbelief for a moment. So, we are going to use the following measurements to find the location of a capsule. It's about 11 feet from the oak tree. I'm not smart enough to say how far and what direction it is from the oak tree. Apparently not. So it's just somewhere 11 feet from the oak tree. So that is a radius. My oak tree is centered at 0, 0, and then I'm going to go 11 feet away. All right, this grid is measured in 4s. So 11 would be just a little bit before 12, which would be 3 grid squares. So there's 11, there's 11, there's 11, and there's 11, and we are going to draw the best circle we can possibly draw. All right, and then we've got it 8 feet away from the flagpole, which is at 0, 8. So 0, 8 is right here. That's my point, 0, 8, and it's 8 feet away. So I'm going to go 8 up, 8 right, 8 down, and 8 left. And I'm going to draw another circle. And then it's 4 feet away from the mailbox at -12, 8. So -12 is right here, 8 is right here, and it's 4 feet away. So one direction, makes me want to sing. 4 in every direction, and we've got our circle here. So it's pretty apparent to see that my time capsule is located right there at, let me see, that would be -8, +8. So it's the point of intersection of all 3 circles. And this concludes our lesson on circles. Please be sure to do the notes check and ask me any questions that you have in class when I see you next. Thanks. Bye.